Hi everybody, this is Ryan and I'm here for another video. This time we're going to talk a little bit about historical counting systems. So here's our learning goals. So we're going to understand early counting systems and their representation of numbers, recognize the chronological order of counting systems development, and convert Arabic and Roman numerals to base 10. So, historical counting systems, the number system we use today did not develop overnight. The numerical system, digits 0 to 9, and the base 10 positional system, ones, tens, hundreds, etc., took centuries to be what we know today. Counting boards use different locations and different sized compartments to denote varying weights to count by. So, an example of this might be an abacus, but the Kupai used chords and knots to efficiently count. Each chord and knot location had a different place value. Roman numerals use symbols and arrangement to denote if you were to add or subtract values together to create the final count. Here are some examples of different timelines of counting. There are 7 main counting systems that lead to our modern day system. The earliest ones date back to the 3rd century BC. So here are some examples of kind of where we came from. Probably of all of these, one that we utilize a lot today is the Roman numeral system. That's still used a lot. Like you see that in Super Bowls, in Olympics, and things like that. That's probably the most prevalent one that still is around. So we're going to talk a little about Roman numerals. So Roman numerals, a system of numerical notation that originated in ancient Rome. They used 7 letters from Latin alphabet to denote specific values. The I is 1, the V is 5, X is 10, L is 50, C is 100, D is 500, and M is 1000. Now, there are a few rules, or there are actually 2 rules that we need to understand when we're dealing with Roman numerals. And they're listed right here. Here's the first one. Take a look at that real quick. So the first one says if a smaller number appears before a larger one, you subtract. So if I was to do a number like 1987, notice how this 1 appears before the 9. That means we're going to subtract. That makes sense? The 1 before the 9 means we're going to subtract in that location. The second rule is if the smaller number appears after the larger number, you add. So notice this 8. This 8 appears after the 9, so we're going to add. So let's look at a couple of examples. So here's the first one, 78. Oh, I'm sorry, 73. So 73. So notice how the smaller number, which is the 3, the smaller number appears after the larger one. So it appears after the 7. So that means we're going to add. So if we think of 70, we can think of 70 as 50 plus 10 plus 10. So notice we're adding because the smaller number is after the larger number. So we're going to add. So we do 50 plus 10 plus 10. 50 is an L. Each 10 are X's, so LXX is a way to write 70. Then how do you write 3? 3 is I. So 73 would equal LXX I. So it'd be this one right here. So that's an example of how you utilize Roman numerals. Let's look at one more. Let's look at one number like 1987. Let's break it down. So we know we have 1,000. We know we have 900. We know we have 80, and we know we have 7. And we got to convert all these different places. So the 1,000 is pretty easy. That's just an M, right? That's an M. Oops, I lost my thing. Oops. So we need 1,000. That's an M. We need 900. Now 900 is a little bit different. So notice the 900 is after a smaller number. So since the 900 is after a smaller number, we subtract. So we're going to subtract 1,000 from 100. Sorry, so subtract 1,000 minus 100 to get 900, and the way to write that would be CM. That's subtracting 100 from 1,000. So that's a CM. And again, it's a smaller is after a larger. And we got, what we got next? We got the 80, right? 80. So this time the 8 is after a larger number, so we add. So that's going to be 50 plus 10 plus 10 plus 10, which is going to be an L, right, which is 50, and 3 X's. And then we have a 7. Now notice the 7 is after a larger number, so we're going to add. So that's going to be a 5 plus 1 plus 1, which is going to be a VII. So if you put all that together, 1987 is going to be MCM L and XXXX, whoops, X, and then VII. That is 1987 in Roman numerals. Now, so other work we need to do is base systems. So also known as a numerical system are ways to represent numbers that rely on specific base or radius to structure the notation. The most common base 10, the most common is base 10, which uses 0 to 9. So base 10 is our counting system. That's what you're used to. That's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Other systems that use other bases these are common for computing a digital system. So binary, base 2, octal, base 8, and hex, base 16. So here's your process to converting from base 10 to base B. So the first step is to find the highest power of base B that will divide by the given number. Write down the whole number, use a remainder, and find the next highest power of base that will divide. Repeat until the remainder is smaller than the base. All the whole numbers from dividing and find the remainder make your new number. All the whole numbers from dividing and the final remainder make your whole number. So let's take a look at these. So let's take a look at the first one. This one is converting base 10, 45 to base 2. So since it's base 2, we're going to divide by 2. So we're going to go 45 divided by 2, which is 22. So if I take 2 divided by 45, that goes in there 2 times. And actually, sorry, let me do that. Let me start that again. So when I divide 2 into 45, 2 goes into 4 2 times. Subtract. 2 goes into 5 2 times. So that remainder of 1. So this would be 22 remainder 1. Now we take 22 divided by 2. That goes in 11 times with the remainder of 0. 11 divided by 2 is 5, and that's going to be a remainder 1 again. And then 5 divided by 2 is 2, remainder 1. 2 divided by 2 equals 1, remainder 0. And then 2 divided by 2 is 1. And then 1 divided by 2 is 0, remainder 1. And then we're done. So the way I would rewrite 45, so 45 would be equal to 1, 0. It's your remainders is what you want to look at. So 1, 0, 1, 1, 1, 0, 1. So 1, 0, 1, 1, 0, 1 is going to be your answer. So it's going to be letter B. So now, if you want to convert it to a base 8, you do the exact same process, except you take 73 divided by 8. So 73 divided by 8, use your division. That's going to be 9. 72 is remainder 1. So that's going to be equal to 9 remainder 1. And then 9 divided by 8 is 1 remainder 1. 1 divided by 8 is 0 remainder 1. So that would be 1, 1, 1 would be that conversion. So essentially what you do to convert is you just do continuous division and take it to the point where your numerator is smaller than your denominator and you're done. And then you look at the remainders to get your answers. So hope this helped. If you have more questions about this, please let me know. It was nice visiting with you today. Thank you.